Welcome to this second module 2 of the HVAC design of hospitals and healthcare facility. Before I go into this my class, and let me recap what we have studied in module 1. In module 1, we have studied the basic difference between air conditioning for healthcare facility and that of the other building, normal building, and the importance of support system in a hospital. Plus, we also studied what is indoor air quality and its importance in the hospital HVAC design and the potential causes of poor air quality in a hospital. We also studied the principal contaminants causing poor indoor air quality in a hospital, the need for the fresh air ventilation we have studied, and its importance to indoor air quality and energy cost of the HVAC plants. Infection control, we studied about the infection control, HVAC design for infection control. We also studied about the air filters, ducts in HVAC system and the relation to indoor air quality and different kind of isolation. In this module, let us learn what are the main routes responsible for infection in a hospital and uh, what type of HVAC system we use and their equipment and their design. In brief, we will study as a quick review so that in later modules, we will study more detail and then we will also work out on the design aspects and then we will teach you how to select and how to install and all the things, the difficulties, installation time, commissioning time, and then maintenance time. And then basic refrigeration system and components. This is what we are going to study in this module in that. Actually, you should understand hospital means other always associated with infection. So there are three main routes which are responsible for the infection in a hospital. The first one is contact route. Second one is droplet route. Third one is airborne transmission. Let us see one by one. The first one is the contact transmission. That means it can be a direct one or indirect one. So direct contact transmission means it involves directly body-to-body contact for the transfer of the microorganism from an infected person to a susceptible host. And that is one of the reason generally in a hospital, they don't allow children below 10 years or 8 years old where the immunity is very low. When they go and they also they touch the bodies of the infected person and they carry the infection and then it will spread everywhere. Another one is indirect. Another type of contact transmission is indirect contact transmission. This involves the contaminants of an inanimate, that's objects such as instruments or dressings by infected persons. This is all called as indirect transmission. This is one of the first main route for the responsible for the infections in a hospital. Second one is droplet transmission. So from the name itself, you can understand a patient, infected person who is admitted in the hospital, he sometimes when he speaks, the saliva will come, or when he coughs, the droplets will come, and that will settle down on the floor. That will remain in the air, but after some time it will settle on the floor. So you have to understand that droplet transmission is do not remain suspended in there for a long time. So we don't need a special air handling in and ventilation system to prevent the droplet transmission. But the floor housekeeping and cleaning, that is the part of the facilities management, they should understand the regular cleaning of wall, floors, and all the things. This is basically the second route called as a droplet transmission. Then come to the third route, that is airborne transmission, which probably we are so much interested. So the airborne transmission occurs when, for example, a person is coughing and sneezing. He expel actually some of the droplets from the respiratory tract, result in a large numbers of bacteria or viruses entering the air in a smaller droplets. These droplets rapidly evaporated the air, leaving a residue of typically about 5 micron size or a smaller in size. These droplets, nuclei, settle so slowly that they remain airborne in occupied space. That means we have conditioned space and circulates on air current. Because you should understand, when we have an air conditioning means it's a closed environment. Air is either taken return air or 100% fresh air. Air currents are always generated. It can be positive pressure, negative pressure, or neutral pressure. So this type of droplets always settles in the air and circulates in the air current. So this is basically called as a droplet nuclei transmission. And then another one is a dust. Dust is in the sense the sick patient sometimes infectious patient capable of causing an outbreak of infection even after the departure of the infectious patient from whom the pathogens originated. Dust may become contaminated when a dried sputum or another infectious segregation suspended in the air as a dust particles mix with the environmental dust. So these are the three routes for the transmission of the infection in our hospital in that. So you can understand the infectious droplet nuclei when he coughs, how it goes, the return air is taken and it goes back. And then again, the person who is breathing, it's inhaling, it goes to the lungs. So this figure itself is a very self-explanatory. You can understand how this droplet nuclei transmission travel within the buildings, within the controlled environment building in that. Now I try to talk about the impact of airflow on a room particle contamination. We know that air changes per hour. Normally, you all basically HVAC engineer know how much air changes per hour based on the ASHRAE or SIPS gauge we take it, depending upon the different applications. Ventilation is very important. But as I told you, the more you take the fresh air, the more load on the system. And plus, we also use different kind of filters in air handling unit for various levels of quality level of air we want to maintain. There are we call as free filters, we call fine filters, and then we have absolute filters, and then HEPA filters, and sometimes even we call as alpha filters in their handling units. But you see that these all, whenever the air changes per hour, it increases depending upon the efficiency. This is a graph chart, how this impact of airflow affects the quality of the air. But you have to understand, the more air changes per hour you want to give, but at the same time, your efficiency of filters that gives so much resistance, and you have to go for the higher static pressure of fan that will have energy. It may not be energy efficiency in that. So this all you have to consider, but I'm just giving a guideline which I have taken from some of the research papers for you with that. And another one on interesting study, which I have taken also from the research paper from Chartered Institution of Building Service Engineers from UK. They have done study. You can understand. I know how many of air conditioning engineers visited hospital in operation theaters. Before you cannot directly enter into the operation theater. Before we enter into the operation theater, whether whoever it is, whether surgeon, patient, or nurse, architectural, normally the medical process, the complex design of the building is there are some rooms actually, adjoining room near to the surgical procedure that are maintained in a different kind of airflow, different kind of ventilation requirements, with different kind of pressure level. So here in this figure, you see that the middle one is surgery one. So that you can see the bacterial count, which was lively taken. The bacterial count in a surgery room is in normal surgery. You can see that it is very relatively low in that surgery room compared to the other rooms. Why? Because of the higher air pressure within the operating room, because that is the reason we normally do laminar flow in operation theaters, and we also use the HEPA filters there in that. So that is the meaning of this air movement. Very important points. As an air conditioning engineer, normally when we design the normal comfort air conditioning for a building, we don't consider this type of complicated things. But when you are planning to design a hospital, this all you have to consider. You have to consider in your design aspect in that. So now having seen that, as I told you, hospital and infection both are, or in any hospital, always infection is there. So that special type of design, the HVAC design, we have to consider that aspect. That's what I discussed with the three main routes. Now let us understand how the HVAC system, because the heating, ventilation, air conditioning system, whether you design for a normal building, for a hospital building, how it differs. That's what we are going to see. We are going to see now in this section. Any HVAC system engineer, before they do, they normally call the data collection. The correct data has to be collected from the end user or the owner of the hospital or anybody, the basic data for the design, ambient conditions. Like for example, ASHRAE, SIPS, they have their ambient conditions from the weather data. Like if in India or even Gulf countries, there are weather data are available, and you have to take the ambient conditions properly correct. And then you should also understand when we take the ambient design condition, the seasonal also you have to consider. There is a summer, monsoon, winter, and sometimes spring. So the ambient conditions keep on varying. And you have to also keep in your mind the peak load always occur once in a day, maybe for a few hours. But we have to select the equipment on that is called as a factor of safety. So these all the design engineer as a HVAC design engineer, you want to also select the optimum design plant, but at the same time you have to also use your creativity in selection of this type of equipment because the basic fundamental of HVAC system design engineer is to start with the data collection, then followed by the heat load estimation or cooling load estimation. In fact, we should call as a cooling load because most of air conditioning system in this part, particularly India and Gulf countries, we use only for cooling and dehumidification. Probably when you design any of the system hospital in Europe or in America, certain parts of America, we may have to do the heating because there we have a long winters. So the heat load or cooling load, there it normally in olden days, about 30 years ago, most of the people they do manual. From the architectural drawing, they take areas and then construction details, and then they take the U value, simple formulas. This I'm not going to repeat because I presume that everybody is familiar with the heat load calculation. And then nowadays it's more easy because there are a lot of softwares are available for the heat load calculations, and you have advantage of that one. It makes your work very easy. It's a powerful simulation tools. You can do even hourly analysis, peak load analysis. So this helps you to select optimum plans. Thereby, you make your design more economical and more optimum also in that. That is very important in that. And but when, as I told you, from the heat load, we are going to select the various kinds of equipments in what kind of equipments in a HVAC system. This also in a brief, I want to review it in the next slides in that. But before that, you should understand the clear understanding about psychrometric chart. So psychrometric chart basically is always in any area, air conditioning engineer, it's a basic, it's another psychrometric chart which we study about the air and its various, how we are going to treat the air. That is called a psychrometry. We have a chart, psychrometric chart. It has different kind of pressures, atmospheric pressure, above as per the altitude, different charts are available. So various process normally can be sensible heating, sensible cooling, humidification, evaporative cooling, heating and humidification, cooling and dehumidification, and heating and humidification. This all probably you have to draw, and then you have to draw your process into the psychrometric chart from the outside ambient condition to the indoor condition. Accordingly, you have to select your equipment. So I know everybody, the basic mechanism of psychrometric chart, you are familiar because you all are the air conditioning engineers. You already qualified as a part of your air conditioning basic degree qualification in that. Now, when we do that one, especially just to quickly review on that, I know majority of the time when we do this type of calculation, people always get confused about the sensible heat and latent heat. So at this stage, I thought that I can quickly review these three states of matter, that is solid, liquid, and gas. I always take water because water is the normal one we use. When water is in ice, it is solid form. When water is water, in liquid form, it is liquid. Then water becomes steam. It is basically called as a gaseous form. Of course, there are some more other matters also, which I am not coming now. We are interested only on that. Then you have to understand the phase change because the entire application of refrigeration, air conditioning is one of the application of refrigeration. The refrigeration process consists of four process. That is, you start with the evaporation, then compression, then condensation, then expansion. So every state, especially the medium or refrigerant, it undergoes various phase change. Like it may be some places it is liquid to gas, some places gas to liquid, and some places it's the two phase in that. So you should understand that one. That's what normally we call as a phase change. This all is the basic fundamental. You may be knowing just for your quick review I have given. So you should understand, for example, when it absorbs the heat when phase changes in that direction, for example, solid, liquid, gas, and releases the heat when phase changes in that direction from gas, liquid, and solid. It releases actually. So evaporation is a phase change process in which liquid absorbs the heat to change the gas. Because in the evaporator, what happened? Liquid refrigerant entering and it absorbs the heat, thereby producing refrigeration effect, and it changes to a gas. So this is how you have to understand. Whereas in the condensation, what is happening? In the condensation, just opposite, because the vapor is entering from the high pressure, high temperature vapor is entering into the condenser from the compressor, and then it gives up the heat to the atmosphere or ambient or the medium. If it is air cooled or water cooled, then it becomes as a liquid, and then high pressure liquid in that. Okay. Now come to the sensible heat and latent heat. From the name itself, you can understand. A sensible heat is the one which senses the heat and which indicates, and latent heat is the one which is hidden. For example, you take ice, let us say, 1 kg of ice in some vessel, and if the ice temperature is, let us say, -10 degree, and you put in the oven or in the gas burner, and you supply the heat, and you can see when you supply, let us say you supply the heat, you put the heat as input, put the thermometer also in that vessel, immediately you see -10 to 0 degree, sharply the temperature will come down, 0 degree. As soon as it reaches 0, you can see that the solid ice starts melting, and then the result temperature remains constant. But whereas you are supplying the heat, isn't it? Where the heat goes, that heat is called as a latent heat, the heat which is hidden inside, because it is trying to change the phase from solid to liquid. From that means ice is converted into water in that. So that's what you have to understand. So we know that in atmospheric pressure, the boiling point of water is 100 degrees centigrade. The freezing point of water is 0 degrees centigrade. This is all basic physics. You must have studied all the things. Just for your quick review, I put the sensible and latent heat in there. This is a simple thing, how the refrigerator, because refrigeration is the basic for the air conditioning. Air conditioning is one of the applications of refrigeration. Refrigeration has got many applications in that. So as I told you, this you have a compressor. From compressor, you have a condenser, and then it comes to the expansion. Then it is going to the cooling. That is called as a evaporation. In a figure way, I put in there. So we have a refrigeration system. There are various types: vapor compression, vapor absorption, many types: steam jet, refrigeration by liquefaction of gas, vortex, thermoelectric cooling. But almost 85 to 90% of the conventional systems are based on vapor compression refrigeration system. Little bit on vapor absorption system. Nowadays, people are taking all other types are in a laboratory stage, still not much commercialized. But I hope that in future, probably this type of other laboratory-based refrigeration system will be also commercialized, because the conventional vapor compression system is highly energy intensive. You understand, you should know that almost 15 or 20% of the energy produced in the world is used by refrigeration air conditioning applications, maybe more than that also. This is what the International Energy Survey is telling in that. So now everybody talks about EER, energy efficiency ratio, seasonal energy efficiency ratio, but everything has got a limitation when it comes to conventional vapor compression system in that. Anyhow, that is not my point, but I just want to know, I want to tell you, majority of the air conditioning system which we use in a hospital is based on the conventional vapor compression system only. Very, very, very rarely we use vapor absorption system, another type of system. Then come to the refrigerant. It's a quick review. As I told you, it is like a medium through which the heat is absorbed from the substance to be cooled, and it is discarded to the atmosphere. So there are primary refrigerant and you have a secondary refrigerant. Primary refrigerants can be chlorofluorocarbon, hydrofluorocarbons, ammonia, natural refrigerants, ammonia, sulfur dioxide, hydrocarbon, and all these type of primary refrigerants. But in that, the chlorofluorocarbons are almost stopped now. The no refrigerant system is coming with the CFCs, but still HCFCs, HFCs are there. But there are a lot of discussions going on that. That is not our purpose of this module, but general idea I'm giving in that. Then we have a secondary refrigerant we call as a chilled water system, and then we have a brine solution in that. But majority of the hospital, we use the chilled water system in that. Chilled water brine applications are very rare, mostly used if you have any big cold rooms or something are there. In the refrigeration, major parts of the refrigerations are, we have four parts: compressor, condenser, expansion valve, and evaporator. The compressor can be further classified four types like reciprocating, screw, centrifugal, and rotary. In general, reciprocating is a very conventional olden days technology. It's simple like engine actually, cylinder, piston. And then centrifugal is based on the centrifugal principle. And the centrifugal compressors are in a higher capacity, minimum capacity start from 200 tons. And then most of the refrigerator hospital air-cooled compressors are either screw or scroll. But the small unitary type of compressors are either rotary or reciprocating in that. Then when it comes to the condenser, it can be air-cooled or water-cooled and evaporative, but generally air-cooled or water-cooled. Evaporative we don't use much in the hospital. It is mostly used in the industrial applications. So let us concentrate only about the air-cooled and water-cooled. Water-cooled is obviously more efficient than the air-cooled, but like countries like Gulf countries, water is very, very rare and very expensive. So majority of the time, they go for air-cooled refrigeration system because for them, space is not a problem. But places in India like Mumbai and Delhi, we have space is a premium. So we go for a water cooled, and water cooled is more efficient. Why? Because water has got high heat transfer coefficient than the air actually. Then evaporator, we have DX type and flooded type. And then when it comes to expansion device, it can be a capillary tube or automatic expansion valve or thermostatic expansion valve and float valve. And capillary tubes are mostly used in a smaller unitary type air conditioners. And then for a bigger unit, higher capacity unit, we use either AEV or automatic expansion valve or thermostatic expansion valve. When it comes to control, we have a humidistat, we have a thermostat, and then we also monitor various types of indoor air qualities, cleanliness, and all the things in that. So you should understand the definition of what is air conditioning. As I told you, air is a mixture of always dry air and plus water vapor. Dry air is again a composition of oxygen, nitrogen, carbon dioxide, carbon monoxide, and water vapor is always depending upon the moisture level in the air. They do not react. Moisture and dry air do not mix chemically. They do not react chemically with one another. Though they are together present in the mixture, each acts independent of the other. That's what we call as Dalton's law of partial pressure. So the partial pressure of air and partial pressure of water vapor, that is the total pressure. So by the name itself, air conditioning is basically to maintain or to alter the temperature and moisture content to suit a specific requirement depending upon the inside requirement. So the refrigeration is used to cool the air and also for removing the air, its moisture content to specific level. So you should understand air conditioning is one of the applications of refrigeration in that. Different kinds of air conditioning, comfort air conditioning, and process air conditioning. Generally, when it comes to hospital, it is like a process air conditioning. Probably when we will do our actual design, that time I will explain you more on that. So when you come to this is based on the air conditioning, then air conditioning, types of air conditioning, we have unitary type. We call window units, split units, and package air conditioners. These all generally very rarely used in a hospital because with this type of unitary air conditioners, we may not have much control on that. So generally we use mostly the central plant only in air conditioning in big hospitals. But maybe if it's a small polyclinic or healthcare, small primary health center where you don't have much area, a smaller area, then in that case, probably we may go for a package air conditioners with a ductable package unit or ductable split units. This is all you know that actually, depending upon that. But still, I don't advise because even because in that that healthcare center, small primary health center may not have a complicated specialties like we may not have the ICUs, they may not have the operation theaters and all the things in that. So in that case, we can go for like a package air conditioners, ductable air conditioners like that. Now come to the central air conditioning plant, we may have a direct expansion system or chilled water system in that. So majority of the plant, we go for the chilled water system in that. I'm just showing some photos of a hospital, one of the 280 bed hospital. This is basically air-cooled chillers. It has got two circuits. These compressors are mostly reciprocating compressors. Probably these chillers are installed in 1980, 88, 89, and still it is working. And these are approximate capacity of the chillers are total. Six chillers are there. Its capacity was approximately 1,800 tons total, actually. Maybe each chiller is 300 tons in that. So major part of the any central air conditioning system in a hospital is chillers, which I have shown you. Then we have a pumps for circulating the chilled water, but that were air cooled condenser. If it is water cooled, then you may have a cooling tower also. Then we have air handling units, which is where the air conditioning is being taking place. Air handling units or fan coil units. Then we have a cooling tower. If it is a water cooled system, then we have interconnecting piping. Then duct network, air distribution network for distributing the air, uh, distribute the conditioned air. These are the major components in that. This also we'll see actually. So I'm just going to show some of the photos like air handling units, how the photos, how the plant rooms, the primary pump and secondary pumps, and in the plant room, how this blower, backward, forward, normal curve. Then we also show microprocessor control in chiller. Now most of the chillers factory built superheat based on the microprocessor control. There are some control room. We will also learn about the building management system later in the other modules, other part of the modules. So see, these are some of the pumps in that. You can see this plant room, how this air handling unit is kept in that. You can see the ducting, some fresh air, some return air. You can see that fresh air units, when it's not insulated, it's a fresh unit. And you also understand the conditions of the ducts if you don't maintain it properly, and you understand how the infection will spread. These are some of the ducts I have taken from a hospital only, just for a get an idea in this model. And then you have to also understand the location of the fresh air unit, because you can see that you there are some exhaust. From the exhaust, there is a nearby, there is a fresh air unit intake. So the air or current will create something, and then all this smell, whatever the dust particle, again into the air handling unit room. So these all you have to see probably when we are going to the actual design, we'll understand just for guidance purpose only. So in this class, in this module 2, we have seen the main 2 points, that what are the main routes for the infection. There are three types of routes which you have described. And then we also quickly reviewed the basics of refrigeration and air conditioning types, different kinds of air conditioning system. Generally, we use in a hospital in that. So we will see you have any questions on all the things. Probably there is a way how you can send it through mail or maybe chat. We will always have. I'm ready to clarify all the things, and I'll be happy to answer all your queries. And let us now go to the module 3 in the next class. Thank you very much. God bless you all.